there's two types of kinetic energy. There's translational and rotational. Translational is when we have an object moving through space. So we call that translation. If it, originally was here in space, now it's over here in space, that means it's moved through space.
Also known as linear.
So yeah, well, it doesn't even necessarily have to be linear, because it could translationally go, all over the place in non-linear paths. And you would split it up into components. So if it was like a projectile motion type question where it arched, then we would do what we used to do back at the beginning of the semester, where we'd say, okay, the y component and the x component, and then you could figure out its velocity, and then its kinetic energy as a result of that velocity.
So linear is just straight, and then translational can be any direction.
Yeah, translational is just moving through space versus rotational, which is spinning and not moving through space. And then a lot of times we have both things happening. Like if I was to fling this eraser, it would be spinning and it would be moving through space. So then it would have translational and rotational kinetic energy. And so the equations are very, very similar. For translational energy, that's the one that we're familiar with. That's 1/2 mv squared.
Okay.
Rotational is pretty much the exact same equation, but now we've got our rotational substitutes. So it's 1/2. The rotational version of mass is this thing called moment of inertia. The rotational version of velocity is omega. So they're the exact same.
Okay.
Just one has the linear type variables and one has the rotational type variables.
Okay.